Hello students, so we are studying the centrifugal compressor module, and at this topic, so already we have solved one problem numerical, and we will solve one more numerical from this topic, so that it will be understandable, so we'll understand it better. So the second numerical goes like this: a centrifugal compressor runs at a speed of 15,000 rpm, so it is given as 15,000 rpm, and delivers air at 30 kg per second. Exit radius is 0.35 meters, and relative velocity and vane angles at exit are 100 meters per second and 75 degrees respectively. Assuming axial inlet and inlet stagnation temperature and pressure as 300 kelvins and 1 bar respectively. Calculate torque, the power required to drive compressor, ideal head developed, work done, the exit total pressure is equal to 1.005 kilojoules per kg Kelvin. So this is the problem which is given. Now we will we'll write down the data for this. So speed is given as 15,000 rpm and delivers at 30 kg per second. So mass flow rate, 30 kg per second. Exit radius, that is R2 is equal to 0.35 meters. So relative velocity and vane angles at exit. So relative velocity is nothing but VR2, that is 100 meters per second, and so 75 degrees, that is blade angle beta 2 at exit. And next, axial inlet implies alpha 1 is equal to 90 degrees. Then inlet stagnation or total temperature T01 is equal to 300 Kelvin. Inlet stagnation pressure P01 is equal to 1 bar. So Cp of air is equal to 1.005 kilojoules per kg Kelvin. So to draw velocity triangles, the velocity triangles are shown in figure. So we know how to draw the inlet and outlet triangle of centrifugal compressors. So in this we'll find out the torque. Torque is nothing but T is equal to m dot into Vu2 R2. So to find Vu2 from triangle O2DE, so this is from exit triangle. So we need to find out the torque at the exit. So cos beta 2 is equal to, that is nothing but O2DE in the triangle. So cos beta 2 is opposite side by hypotenuse, sorry, adjacent side by hypotenuse. Here adjacent side is U2 minus VW2 is the adjacent side, divided by hypotenuse is equal to VR2. So in this VU2 is unknown, so VU2 is equal to U2 minus VR2 cos beta 2. So U2 is written as pi d2n by 60. So if you substitute, you will get to 549.77 meters per second. So from equation 2, VU2 is taken as 5499.77 minus 100 cos 75, that is 523.89 meters per second. So from this we can find the torque. Torque is equal to, as it is written in the formula, m dot into Vu2 into R2. So Vu2 is 30 and m dot is equal to 30 and Vu2 is equal to 523.89 into R2 is equal to radius 0.35. So it comes, torque comes around 55,500.9 Newton meters. So next we'll find out the power. Power is equal to torque into omega. That is angular velocity. Torque into angular velocity. Angular velocity formula is equal to 2 pi n by 60. Then 1570.8 radians per second. So power is equal to torque 55,000. So 5500.9 into omega, angular velocity is equal to 1570.8, which is 8.64 megawatts is the power. So next one is to find out the ideal head developed, that is H. So ideal head is equal to U2 VW2 by G. So U2 is nothing but pi dn by 60. So into VW2. So pi dn by 60, pi into d, diameter at exit is 0.7 and VW2 is equal to 15,000 pi dn. So that n is equal to 15,000 rpm divided by 60 into VW2 is taken as 523.89 divided by G is equal to 9.81. So it comes around 29,360 meters of air. So to find work done W, power is equal to m dot work done per kg of air. So work done per kg of air W is equal to P by m dot. So 8.64 into 10 cube kilowatts divided by mass 30. So 288 kilojoules per kg of air. To find exit total pressure P02, so work done is equal to Cp into T01 into P02 by P01 whole to the power of gamma minus 1 by gamma minus 1. So where Cp of air is equal to 1.005 kilojoules per kg Kelvin and gamma is equal to 1.4. So work done already we have found out, which is nothing but 288, that is equal to Cp is taken as the constant value 1.005 into T01 is 300 and P02 divided by P01 pressure is given as 1 bar into 1.4 minus 1, that is 1.4 gamma adiabatic index minus 1 by 1.4 minus 1, or P02 whole to the power of 0.285 is equal to 1.955. So P02 is equal to 10.5 bar. So this is how to solve the centrifugal compressor. So once again we will go do some recap. So speed is given 15,000 rpm and mass flow rate 30 kg per second. Exit radius and diameter d2 0.7 meters. Exit relative velocity Vr2 is equal to 100 meters per second. Exit vane angle beta 275 degrees. Axial inlet implies alpha 1 is equal to 90. So inlet stagnation or total temperature T01 is equal to 300 Kelvin. Inlet stagnation pressure P01 is equal to 1 bar and Cp of air is equal to 1.005 kilojoules per kg. So from velocity triangles, so we find out cos beta 2 and then Vw2 we need to find out. So Vw2 we don't know what is the U2. So U2 will be found out with the formula pi d2n by 60. And then Vw2 will be taken as 523.89 meters per second. So torque T is equal to 5500.9 Newton meter. So power is equal to torque into omega. So where omega is equal to 2 pi n by 60, where 1570.8 radians per seconds. So power is equal to torque into omega. So you'll get the power as 8.64 megawatts. And then to find out so work done is equal to P by m dot. So before that we will find out the head. So finding out the head is U2 Vu2 by G. So you'll get 29,360 meters of air, and then power is equal to mass. So work done is equal to power by mass. So you'll get 288 kilojoules per kg, and then exit pressure. So P02. So for that work done is equal to Cp into T01 into P02 by P01 whole to the power of gamma minus 1 by gamma minus 1. In this Cp is taken as 1.005 kilojoules per kg Kelvin, gamma is taken as 1.4. So in that P02 is taken as, so P02 will be found out as 10.5 bar. So this is how we'll find out the numericals in centrifugal compressors. Thank you for watching this video.